All right.
Good morning, sir.
Morning, Tony. All right.
Sir, can I speak to you after class?
Yeah, sure, sure. Did you get the assignment? Did you get the lab?
So I saw it in the Google Classroom.
Okay. Well, that's what we're gonna go through. Actually, that's what we're gonna go through now.
So you just start class?
Well, yeah, I was waiting on persons to respond to the link, and here you are now.
Sir, I really know wrong with Siobhan. And well, me kind of have some issues lately, so.
Oh, all right. Well, all right, we start that out then. All right, you're gonna stay with us to do this lab, to go through it.
Yes, sir.
All right. All right, guys. So as you can see now, this is your first plan design lab, and I told you would have missed the previous class. You would have missed chemistry class.
Yes, sir. This sachet tell her
Oh
what I
yeah,
said.
yeah, yeah.
Oh,
Did you see Sashi? Oh, you said it would be late. I think that's what she said.
yes, sir.
Okay. I thought it would be late for chemistry class. I thought I
Sir,
don't know.
so me late for eat to board class. There are peer problem I have, sir.
All right, I understand. All right. Well, we can go through that. All right, but in the meantime, we're just going inch towards finishing these labs because again, this is one of the required labs. So we're going to just go through it. You saw the video for the last class?
No, sir. Sir, me
Okay.
go.
All right. Well, I sent the link in the group so you can go and look at it.
So you send the notes to me the ask for, sir, or you can send in the
I
WhatsApp group
believe I
for me
sent
add
it,
it back.
I believe I sent the notes, hey Tony, you have to check. I
No,
believe, let me see. Um, let me see. The notes, that's it for which class? For physics or for chemistry?
sir, both sir can miss out nothing both classes.
Oh, I see. All right, well, a few videos are online of the classes, so you can go back to those, but I don't upload all of them. Uh, all right, so and then that will put you way behind. Yeah. So say that. All right. Anyway, so this is so you would have known as to how to write a plan and design lab. Did you write one before? Because you'd have done
No, sir.
you don't do biology.
Yes, sir, but we're doing a plan and design lab.
Oh, okay. Well, remember that for I know that for physics and chemistry, you're required to have three. So we're definitely going to look at that today. So plan and design. So these labs can be done online. So it's not like the other ones where you really have to be in a class setting carrying out some experiment. This one you can actually do it in this format that I'm going to use now. All right. So and if you haven't written one before, then I'm just going through step by step as to how to do it. All right. So all right. So basically you can see the screen, right?
Yes, sir.
All right. Rachel, you there? Uh, yeah, Rachel was here, but not there. All right. So here we go. With a plan and design lab, One of the first things when you get a lab like this is that you're going to write the skill. So let's write. You can write PD or plan and design. All right. Of course, we're gonna put today's date, even though this lab was to be done from last week. Still going to put today's date. Today's date is the what, 2nd of the 3rd, 2021. All right. Now, so with a plan and design lab now, you get we start out with the problem. All right. Now, the problem is just a statement where when you read it, you realize that you have something to solve. All right.
Sir, sorry if cut in, but yes, sir, we did do two plan design lab, vermiculture and hydroponics in biology.
So you never realize you do them, you do those already. Uh,
Sir.
all right. Anyway, so that's that. So this how you would have written it up.
Yes, sir. Yeah. But we never write the problem though.
Right, the problem. All right then. So this one now is a simple problem. It involves Kanye believing that dark colored objects will absorb more light uh, or more heat than light colored objects. All right. So he observed that when he was using or wearing light colored clothes, that he would not feel as hot as when he was wearing a darker colored clothes. And so he went plan and design an experiment to see if dark surfaces absorb more heat. In this case, the heat is referred to as radiation. All right. So that's the objective here. So with the hypothesis now, usually you are supposed to come up with your own, but then because this is the first plan and design for physics, I'll give you 3 examples of a hypothesis. Now, if you were in chemistry class, I would have gone through what a hypothesis is, but just want to know if you know what a hypothesis is. Hey, Tony.
Yes, sir.
All right, what is it?
So, feel that we um,
Well,
sir, it'll be the method or stuff.
no, actually, no, it would be what you'd use to come up with a method. All right, but a method. Uh, Rachel,
Yes, sir.
yeah, you remember what I said a hypothesis was in the previous class?
Yes, sir.
All right, can you help us out here? What is the hypothesis?
So a hypothesis, sir, is basically telling you what you're planning to do in the lab, what you're going to carry out.
What you going to carry out? So inching closer to the answer I'm looking for. Not quite looking for. I'm looking for something more in terms of that. All right. Let's look at the problem. The problem is that when you're wearing different type of clothing, you feel hotter or cooler. All right. This is something that you would experience. You experience anything like that? I Tony or Rachel?
Yes,
Yes,
sir.
sir.
All right. No, you are saying all right. So would you agree then that if you're wearing dark colored clothes, that you're gonna feel hotter?
Yes, sir.
Yes, sir.
All right. Now, do you know why that happened?
I don't know, sir.
No, no. Yeah, go on.
Sir, I think that the darker color traps more heat, sir. That
All
is,
right. Okay. So darker color will absorb more heat. And
yes.
so you see what you're doing there now? Because you think that's your opinion. That is your hypothesis.
Yes, sir.
Yeah. So basically, you would just choose one of these based on what you just say. What you just said a while ago would sound like the first one, which you get 1 mark for writing a hypothesis. All right, a black material will absorb more heat from the sun than a white material. All right, so basically for this now, I Tony, you just pick one and continue the rest of the lab with it.
Okay, sir.
All right. So all right, let's take number one then. A black material will absorb more heat from the sun than a white material. All right. Second one would say white material will absorb less heat from the sun than a black material, which is the same thing there. All right. And the third one is about metals. So dark colored metals will absorb, so will become hotter than bright colored metals when exposed to the same amount of heat. We're talking about sun here, the sun as a source of heat. So therefore, we can pick any one of these then. All right. So let's put this now. The next thing is to change the hypothesis into an aim. All right. So you remember we did that before, Rachel?
Yes, sir.
All right. How did I do that? How did I change the hypothesis into an aim?
Sir, you put it in the past tense, sir.
Put it in the past tense. Be careful, Rachel. Past tense would have meant that you did that before, which this is the case. You have not done it as yet, so it cannot be in the past tense.
Oh, it's because I know that normally when you're writing up labs, you normally put it in the past tense. That's why I said that.
All right, so you're learning today that the difference now with a plan and design lab is that those labs are written in future tense.
Oh.
Yes, future tense. I really need to highlight that to the chemistry
Yes,
class.
sir, you're right, for sure, sir.
Yes. So the future tense are present tense. So always remember that. All right. So the aim then. So the aim for this lab is then. All right. So then let's see. You're gonna say there are black material. So usually your aim, you don't want to change up the hypothesis too much because you put a lot of effort into finding out or into wording it. All right. So hypothesis is probably hard for students to come up with on their own. So now that you come up with one, you want to keep it simple then. Use the same words in the hypothesis, but change or maybe add one or two more to it. So look at this now. Because the next step is to carry it out. You're gonna say your aim is to determine if determine if to determine if dark. And when you say material, we want to get a little bit more specific here. We could use fabric since that's easy to get. All right. So material is very general. So when you simplify it and say fabric, which means that you can use your clothes at home to do it. So to determine if dark colored fabric absorb more heat from the sun, more heat. So than white, and in fact, yeah, dark colored. So than white fabric. So all right, so that's it. That's our aim. See, now what I did here, I didn't change much. Just say to determine. That's it. See what's happening here?
So you
Yes,
basically
sir.
reword the hypothesis.
Very good.
I'll put it in simple.
Yeah. All right. So this is a start for your aim. You get 1 mark for the aim, by the way. So usually the mark scheme for plan and design labs is that you get 1 mark for the hypothesis, 1 mark for the aim. All right. And of course, the apparatus now should reflect what you're going to use to carry out this experiment. All right. Now, any questions so far?
No, sir.
No, sir.
All right, good. So, because you're saying it's fabric we're going to use, obviously one of the apparatus you're going to use is fabric. So we could use fabric or clothes. Maybe let's keep it. The thing about it is that if you're doing it at home and you're going to say clothes, you don't want it to compare with a shirt or a pants. You know, you want to keep the type of fabric the same or type of material the same. So, but the colors will be different. All right, bear that in mind. So the material would be different. All right, what I said there. Yeah. All right. So yeah, sorry about that. So in the offline there. All right. So now, all right, guys. I hope you understand what I'm saying. So if you're gonna use clothes, make sure the clothes are the same type of clothes. Um. So fabric or clothes, and then let's put a shirt then, for example, or a blouse. So basically, if you're gonna do this at home, get a white blouse, get a like a black blouse, or maybe even a different color blouse that's darker colored, and you compare it. Um, no, of course, if you're doing it at home, you'd need like a thermometer now to test the temperature. So that might be a little challenge for you. I think your phone can do it. Um, but yeah, more on that still. All right. So clothes, shirt, or blouse. And what you could do then, you could even tweak it, and say, all right, wet the two of them, and then hang it up and see which one will dry faster. You can probably check it like every 15 minutes and see which one dry faster.
So do an experiment with the both of them.
Very good. You see that? That's the beauty of physics labs. You can always improvise, use things around you. So so then that would be, yeah, that's pretty much it. In terms of the temperature, we would probably need a thermometer. Um, all right, so Kanye is just stepping in. All right. So, and then what else? Okay. So we can continue here. So we have our apparatus here. I don't think we need much more here. So let's just move on. The diagram now. I did this diagram here because I think when I was carrying it out on my own, I actually used boxes. So, and this was done when we had face-to-face classes. So, but now seeing that you're at home now, your diagram would be a little different. All right. So if you probably can relate to the clothesline concept, let's bring up a clothing line. And let me see. There you go. And we can get creative here. Kanye is having problems connecting. Look at this beautiful image here. What are you seeing this? Maybe something like that.
Yes, sir.
All right. So let's say that they would be like the same type of clothes here. All right. So now this brings us to where's the oh, I don't have the all right. So the features that word. All right. So let's continue. So then we move to the next step, which is the method. How are we going to carry it out? So the diagram is like a hint as to how it's going to be set up. So you realize now that if you're going to do something like this at home, you're basically going to use a clothesline. So that could be in your apparatus too, clothesline. And then that would include clothespins as well. So this is something you can do at home. I never realized this version of this lab here, but clothesline and pins. All right. And that's assuming everybody know to hang out clothes and all that sort of stuff. All right. But method. So what's the first step then? I gave you an idea a while ago, but what would you do to test this now? All right. All right. So let's start with your case then. I remember now, and I choosing this image because notice that what they have is different colors, and then they are the same type of material. So remember, you can use one to make out of cotton and the other one make out of polyester, and say they are different colors, and you're testing it because that would be off. So bear that in mind. All right. So now, your first step, you would be, as I said, wetting or place clothes in water. So, or you could say set up. You wouldn't say set up apparatus as shown. Well, what we could do here, the students normally start with saying something like this: obtain. So, how many colors you would use to prove this then? If it's a dark color, look at how many colors we have here. This is actually 4 colors. And remember that we said in the aim that we want to see if it absorbs more heat than the white. So you're definitely going to need some different colors here. White must be added to this. All right, so you're going to do now obtain, and in that case, obtain 5 colors of clothing. Of the same type. All right, same type. All right. All right, Lennox is just stepping in. All right, so I think Kanye having problems connecting. All right, everybody seen that? Everybody seen the screen?
Yes, sir.
All right.
Yes, sir.
All right. So now let's say you obtain 5 5 clothing up there, colors of clothing. So the same type. So example shirts made from cotton. Let's say that. Let's say you do that. You could say submerge. And guess what? Could get creative. We could really get creative here. We could even use a stopwatch. Look at that. Because why? Remember now, if you hang them out, you're gonna see which one dry the fastest. All right. And if you're gonna feel the clothes, you want to feel the same location of the clothes. So you don't feel the color on one and you feel the body of the other one. No, if you're gonna pick the color or the edge to feel if it dry, stick to that for each of them. Everybody understand that?
Yes,
Feel the
sir.
same part of each clothes when you want to check if them drying. All right, so submerge clothing in water, and you want to ensure it's the same amount of water, probably the same water. All right, so submerge the clothing in water. All right, then afterwards, now you're going to remove. So you're going to basically remove clothing from water. All right, and then you place it on the line. So, all right. Place them. All right, and closing line using pins. And there you go. What are you going to know? After you put them up there now, you're gonna check. So you're going to let's see, check the colors of each the colors of each clothing. We're gonna check the colors of each clothing. All right, so that would be right here. We're gonna feel the top part there. Every 10, let's say 10 minutes.
Sir, right off this here, sir.
You're going to write it off?
Sir, I'm asking you, sir.
Yeah, it's your lab.
Oh,
It's a lab, the same
sir,
lab
and
that
then
you.
I can
If I can, all right. What I'll do now, I'm gonna send this in the group, doing.
Okay, sir.
Yeah, so you can just focus on trying to understand what I'm saying. All right. Then afterwards, no, you
Yes,
can,
sir.
yeah. All right. So check the colors of each clothing every 10 minutes. Next step is to record your observations in a table or in a suitable table. All right.
Sir, I don't know if I didn't hear this, but after when I put the clothes in the water, say ring them or
Oh, very good question. I like that. So you're starting to think now, which is where I want you guys to be. Yes, you can add that step. You can add that step, right, Tony? You definitely know about washing clothes. So yeah. Why not? Just ring them. Ring them out. Because if you ring them out now, maybe that you would spend less time. You'll spend less time on the line. So you could ring them out. As well as you don't have to ring them out either. Either way, them out dry. But then maybe the rain now might be a factor. Say them stay out here too long. Let's say you hang them out early morning and we get a shower rain by say 12 o'clock. Maybe they won't fully dry and the experiment won't be finished. But yeah, ring them out if you want. No problem there.
Yeah, hang them where the sun shines brighter or something like that.
Well, there you go. But that's the next thing now. You want to make sure that each of these clothing exposed to the same amount of sun.
Yes, sir.
Yeah. So if you pick a location, set that location because after the method now, we're going to talk about something called the variables. Them. All right. These are the things that we're going to change and make sure. And some things will change, some things will remain the same. And so far, remember that we said that the same clothes we're going to use, same type of material. So bear that in mind. So yes, I told you can ring it out as well as you don't have to ring it out. But there's advantage into not ringing it out, though, you know.
what's that, sir?
All right, I'm sure this now. When you don't ring it out, you're more sure say they have the same amount of water in them. So when you ring it out now, you're going to ring out 5 pieces of clothes now. So you don't know if one did leave in with more water. You understand than the other. So that would have throw
Yeah,
off
but
the
you leave them.
you see. So I would say you can do it, but you have to go if you ring it out, you can account for it as a limitation later on in this lab. Where
Okay.
yeah, so it's very flexible, but it all depends on you. All right. So all right, so then you're just going to record the observations here. And you can record the observations in a table. Yeah, usually they like tables for these type of labs. All right. So any questions? You basically going to design your
Sir,
table.
the
Yeah.
table supposed to entail like the day and the time.
Yes, you could not the day, just the time, the color. The table must and you asked a very good question there. Let's do a little sketch and see what a table look like for that. So you're basically gonna have the color and then of course like you're gonna say what you're going to feel, and that's gonna be very subjective, but so the all right, so feeling after you see the beauty of this now is that if you had a thermometer you could just put it on it and then it would tell you the temperature. But in this case, if you're gonna feel it now, so feel every and then let's I'm probably going to zoom in and show you. Can fix up this table afterwards. Yeah. So when you feel every, let's say 10 minutes, next time 20, then 30. We're going to know this, just describe how each color feel.
Okay, sir.
Yeah. I remember say every 10 minutes. All right, so these are minutes. So yeah, that's it.
I
Until
feel
it
every
dry.
10 minutes until it completely dry.
Yes. So there you go. And then this is 50. So yeah, up to 50 minutes. Let's say I don't know how long clothes typically clothes like these will take to dry. I don't think they take that long. But do that. So it would be nice to have a black and a white and some other colors in between. So I can redesign this table afterwards though, but in the interest of time, we're going to press on here. All right, so you got the table going to stay like this. So so that's it. Just giving an idea. All right. Now, let's get some more marks for this lab, because what I was saying before, if I plan and design, you'd have gotten 1 mark for the hypothesis, 1 mark for the aim, 1 mark for the apparatus there. I usually give a mark for the diagram. I usually give a mark for the diagram, but that's depending on the mark scheme I'm going to use. But so far you'll get up to 3 marks. When you reach a method, you're getting like 2 marks for that. Results table, we get 1 mark for that. So that's looking at like 5 marks here. And guess what? You get 1 mark each for these variables that we just talk about now. So what do we mean by the variables then? All right, variable. Rachel was in the class before when I spoke about variables. Were you there, Rachel?
Yes, sir, but the internet was freezing up on me, so I couldn't get to hear what you said.
Oh, okay, fine, fair enough. All right, so I'm gonna explain it to everybody. No, the variable is things that can change throughout the experiment. While you're carrying it out, things that can affect the results that are either changing or remaining the same. All right, and so that's what a variable is. Some of you guys should do IT, and that's a part of IT as well. But anyway, control variable. Control variable. Control variable means that you're not going to change this one. You're going to control this. This one will always be fixed. So we just talk about this. We're comparing all of these colors to white. So white fabric. All right, white fabric is one. That's the control that, again, when you use that all the time, the colors can be different. But also, what about the sun? That the sun will be always there, right? Hopefully.
Yes, sir.
All right. So we have a control variable here. We just need like 1 or 2. 1 is good. So you're right, sun, white fabric, and comparing everything to it. Independent variable now, or what we call manipulated variable. All right, is the variable that you are controlling directly. All right, so the variable that you're going to adjust now, because you said that you're going to use different colors, you are controlling the colors, so you choosing the colors. So you are, what we say, the word we use for that is that you are manipulating the colors there. Hence, this is a manipulating variable. So the colors of fabric use is 1. Any questions here? Any questions?
No, sir.
All right. So next step now, dependent variable. Dependent variable. So after you're changing the colors now, what you expect to happen? What you expect to happen to the clothes when you put them up in the sun, different colors in the sun?
Sir, repeat that, please.
What do you expect to happen to the clothes after hanging them up?
Sir, right,
Yes.
sir.
Yes, Lennox, you were saying something?
Sir, expect them to dry.
All right, good. Do you expect all colors to dry at the same rate or the same
No,
time?
sir.
Oh, okay. So which one you think? All right. So therefore, what we're having there is the responding variable then. Is the drying of the clothes.
Black would probably dry first, sir.
Oh, all right, good. Hold on to that, because that will come into the expected results after this. So the dependent variable is the one that went to respond to the colors, and the dependent no, so the drying time. All right. The dryness of the clothing, let's just put in maybe that's a better way to express it. Dryness of clothes of fabric. And there you go. Dryness of fabric. All right. That's responding variable. We also have another control as well, because we're checking every 10 minutes. That's another control with controlling the time. So we're fixing that one. That time is every 10 minutes. So time taken to check dryness. So this one here, what it looks is, so we have 3 controls here, but we have 1 independent, which is the manipulated variable, the one that we are controlling, and then the one that is responding to what we are controlling. All right. Any questions at this point? On the field, you understand this?
Yes, sir.
All right. Good. So then that's it. Three variables. All right. And 3 marks. 3 marks for this, 2 marks for this, 5 marks. So guess what? You can get half of the marks for this lab for just writing a good method and getting the 3 variables. That's 5 marks already. Lab marks out of 10. You're getting not 3 more marks for hypothesis, aim, and apparatus combined. That's 8. And we're almost there. 2 more marks. This is amazing. So the 2 marks you're gonna get is for the expected result and the limitation. All right. So what you just said a while ago, you expect because I think Lennox, you said that you expect which one to drive first, you say?
Sir, black, sir.
All right. All right. Let's just say you don't use black. So you'd write something like the darker colored. All right. So the darker colored fabrics will dry first. All right. Say what? It's expected to. Let me just put that. It's expected to. Notice the future tense here. And then that's it. So I'm gonna stop here for today.
Sir, the table can go in data to be collected.
Very good. Yeah. This right. Because I wanted to move it. So the table that we did here, we could go in the data to be collected. Let me just copy that and cut that out there and put it right where you just say data to be collected. All right, drag it here. All right, that's it. After this, if you can reach this far, guys, I just say just do this lab for next class. That would be the next lab out of the way. And you have 3, well, you have 3 of these labs to do. So this is the one, and you have 2 more labs like these that we can do online. So that should bring up a number to, I believe, 7. And then we just do a few more and close off. Any questions? Yes. Oh, I'm not hearing you. You're breaking up there.
Sir, the
Yes.
lab books.
Yeah. So when in terms of the lab books now, all right, the lab books are at school. So as I told you, you could write them on full of leaf, keep them in a file jacket. All right. Or put them together. That's one. So that when you go back to school now and we get the lab books them, you can put them in there. All right. Remember now, guys, they are not marking the lab book, they are marking the labs. So you have to separate the labs from the lab book. The labs can be done on any material that you have available, especially in these times. All right. The lab book is just like a formal way to organize everything. But if you don't have that luxury now, just do the lab them. Just do it on full of paper. Let me see it, take picture of it, send it to me. Do what you have to do, but make sure so the lab is completed. All right.
Sir,
Yes,
Yeah.
sir.
Yes, can you?
sir, yeah, send that in a group, sir, because
Yeah, this will be sent. Yeah, man, this will be sent. So the video now of this class will be sent as well as the notes.
Aye, sir.
All right. All right now. So we basically finished this stuff, you know. See, let me just get the register here now. So I'm seeing Tony here. And took a while, but we have some well, we have better numbers now. Still not seeing Terika, but so we have Kanye and that's Haynes. And I'm seeing Lennox and All right. And then there's Lennox Hassart. And let's see who else. And Chevon. Chevon. All right. So Chevon and as needed. Okay. Chevon. Chevon last name again.
Hudson.
Sir.
Right. Yeah. Once again. I don't know too much Chevon. All right. So this is actually saying five persons. Yeah. Yeah, because Rachel would have dropped off. All right, guys. So as we say, if you have any questions, just use the classroom, use the group, and just keep in touch. All right.
Yes, sir.
All right. Let me just. All right, I'm gonna save this as you speak now, so that. All right. So this is plan and design, physics. All right. Class. Yeah. And then let's put the date there. That's gonna be actually March 2, 2021. And we'll save that. All right. No. All right. So you should see it in the group in a while, in a short while. All right. So all right, guys. Thanks for coming out today, guys. And enjoy your day. And as we say, guys, just if you have any questions, just use the group. All right. And make sure you do this for next class.
Aye, sure.
All right. All right.